Hello viewers, Wagadaro now taking you through the story of A-level applied mathematics, and this video will be on normal distribution. So this topic is under probability and is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So if a continuous random variable x is normally distributed with mean mu and variance sigma squared, we write this as that. So this represents that x is a random variable following a normal distribution with mean, mu and standard deviation that. So always you must get used with this symbol because we shall use it more frequently. So whatever they put here first will be the mean, and what they put here will be the variance, as long as here there is capital N. The most important normal distribution is the standard normal distribution, and is given by the symbol Z, which has a mean of 0 and a variance of 1. Therefore we write this as, this means that random variable Z follows a normal distribution with mean 0 and variance 1. So like I said, what they put here will be the mean, and what they put here will be the variance, as long as this is capital N. Now we also have to know how to sketch a standard normal curve. So a standard normal curve is of this shape, which is a bell shape. We call it a bell shape. So it will always be of that shape, and here it is symmetrical, and at the center this is 0, mean 0, and the values from 0 going to the right are positive, values from 0 going to the left are negative. So these are Z values. So this is an Z axis, and this is an axis of FZ. And I think we realize that the area which is shaded denotes phi ZP. So this phi ZP is the same as probability. As you can see here, the note says the areas under the curve show probabilities, and that is therefore the shaded area here shows the probability that Z takes on values from 0 to ZP. So I think we see that we shaded from 0 up to ZP. Therefore, when they want the probability that of Z taking on values from 0 up to ZP, in other words, probability of Z greater than 0 but less than ZP, that would be this area, and it's denoted by the symbol phi. So this symbol phi, we shall use it more frequently. It implies that the probability starts from 0 up to this value in the bracket. So if, for example, this ZP is 3, it implies that they want the probability from 0 to 3. If Z is 2.5, it means they want the probability from 0 to 2.5. So that is what this symbol phi means. So you have to be keen of it because we shall use it more frequently. Now we shall start with part A, which is shading required probabilities. So what we should know is that the areas under the curve shows probability, and the curve is symmetrical about mean 0. I think you saw that. According to the shape was in this form, meaning that it is symmetrical. Then another point to note is that the total area under the curve is 1. So this is very vital, because by symmetry it implies that it divides this curve into 2, meaning that this part will have a probability of 0.5 and this one also have a probability of 0.5, but we shall see that in details when you go to the next part, where you have to get individual probabilities. So by symmetry, this area is divided into 2 equal parts. So that is what we need to know at this point. So we shall start with the question, and the question says that represent the following probabilities on a sketched, note that we are using a sketch, not an actual diagram. So on a sketched standard normal curve. Now standard means that at the symmetry there is a value of 0, which is the mean. Standard normal curve by shading the wanted region. Note that we are shading the wanted region. So these are the probabilities: probability of z less than 0.123, probability of z less than negative 1.189, probability of z greater than 1.561, probability of z greater than negative 2.857, probability of z greater than 1.45 but less than 2.990, and probability of z greater than negative 1.002 but less than 0.179. And lastly, probability of z greater than negative 2.999 but less than negative 0.199. So those are the probabilities those are the sketches we shall draw. So let's see how they are drawn. So like I said, we shall start with part A, probability of z less than 0.123. And like I say, the shape of the standard normal curve is the same, so it will always be of that shape with 0 at the center. Then after that, you look at this value. This value is positive. Like we said, if this is 0, positive values are this side and negative values are this side. Now because this is positive, we are going to put it anywhere in this side which denotes positive values of z. So you come and put it somewhere, let it be there. Then next we shall look at the inequality, probability of z less than this. So the values here less than that are from there going this side, because this side means they are greater than, but this sign shows less than, meaning that we are going to shade from here going to the left. So let's do that. So that is the shading they wanted in this part. So like we said, phi denotes probability from 0 to a z value. So from here up to here, it will be a probability of z greater than 0 but less than 0.123, and to be denoted by phi 0.123. Now this other probability, I think realize that the whole of this half here has been shaded. Therefore, like we say that this shape is symmetrical, it implies that the whole of this probability is 0.5. So we shall come and put there 0.5. So that is the sketch of part A. Now we shall go to part B, where they want probability of z less than negative 1.189. So it's somewhat similar to part A, but this time there is a negative there. So what we shall know that always the sketch of the standard normal curve is the same, so it will be that with 0 at the center. Then we shall look at this value. This value is negative, meaning that it will be somewhere in this region. So let's put it there. After that, we shall look at this inequality, z less than negative that, meaning that negative is always to the left. So when they say greater than, it will be to the right, but this time they say negative, so we shall shade going to the left. So from, like I said, from the probability from 0 to a certain value is denoted by phi. So this phi negative 1.189 means denotes the probability of z taking on values between this and that. So what does that mean? It means that this one, which is remain left, is equal to 0.5 minus this probability. Remember, the whole of this half from here up to the end has a probability of 0.5. Therefore, if from here up to here is phi negative 1.189, it implies that the remaining part will be got by saying 0.5 minus phi negative 1.189. So these sketches are very vital because they are going to help us in the next step of this topic. So now we shall go to probability of z greater than 1.156. So somewhat similar, but this time instead of saying less than, they have used the word greater than. So we shall first sketch a standard normal curve, which is always the same, with mean 0 at the center. Then we remember that this value is positive, so we shall put it anywhere in this side part. So let's say it be there. Then next we shall look at this inequality greater than. Like I said, greater than means that we're shading going to the right, so we are going to shade going to the right, and that will be the shading. Then after that we shall remember that the probability from 0 to a z value is noted by phi, so the whole of this from here to here is phi, but the total is 0.5, meaning that this part remaining, which is actually shaded, will have 0.5 minus phi of 1.561. So these sketches we are drawing are very vital for the next step. So you should make sure that you understand every step that we take. So now we shall go to part D, where they want probability of z greater than negative 2.857. So somewhat similar to this, but this was positive and this is negative. So we shall first draw a standard normal curve with mean 0 at the center. Then we shall look at this value. This value is negative, meaning that we shall put it anywhere this side of 0. So let it be at that point. So after that we shall look at this inequality greater than. We said greater than means that you shade going to the right, just as the arrow points. So we are going to shade the whole of that. Then you should remember that probability from 0 to a z value is denoted by phi, so the whole of this probability is phi of negative 2.857. And I think you see that this other half, the whole of it is shaded, meaning that the total probability will be 0.5. So now we shall go to part E. So part E, the one the probability of z greater than 1.542 but less than 2.990. So now that they want to shade from the values of z range from the 1.542 up to 2.990. So the sketch first of all is a standard normal curve, which is always the same with mean at the center. Then after that we shall look at these values. Both of them are positive, meaning they will both be this side. But if you look at them, this one is smaller than this, meaning that 1.542 will be closer to 0, so let's put it there. And then this will be further from 0, so we shall put it there. Now the shading they want is from this up to this, so we are going to shade the whole of this area. Okay, so now like we said that phi denotes probability from 0, so phi of 2.990 is the whole of this from here up to here, and phi of 1.542 is from here up to here. Now if I want to get this balance, it means that I have to subtract phi of 1.542 from phi of 2.990. That is why here you see that the shaded area is equal to phi of 2.990 minus phi of 1.542. So all these steps we are taking are very vital, so you ought to be following. So now we shall go to part F, where they want the probability of z greater than negative 1.002 but less than 0.179. First, sketch the standard normal curve, which is always the same with mean at the center. Then when you look at these values, this one is negative and this is positive. Now the negative value will lie this side, so let's put it somewhere there, and then the positive value will lie this side, so let's put it somewhere there. Now the values they want is from here up to here, meaning that we are going to shade from this going this side up to there. So let's do the shading. Okay, so now after that we remember that phi means values from 0 to a z value. So this phi of negative 1.002 denotes probability from 0 up to negative 1.002, and this phi of 0.179 denotes probability from 0 up to 0.179. So when we add all these two, we shall be able to get this probability which they want. And lastly, part G wants probability from z of z greater than negative 2.999 and less than negative 0.199. So first of all, we shall sketch the standard normal curve with mean at the center. Then we shall remember that both these values are negative, but the question is which one is closer to 0. You realize that it is negative 0.199 which is closer to 0, so we shall put it there closer to 0, followed by this which is further away from 0, so we shall put it somewhere there. Now the values from here up to here will mean that we are going to shade from here up to there. So let's do the shading, and that one will be denoted by phi of negative 2.999 minus phi of negative 0.199. Remember we said phi denotes probability from 0 up this value, so phi of negative 2.999 is denotes probability from here up to here, and phi of negative 0.199 denotes probability from here up to here, meaning that the balance will be got by subtracting the two. So now we have learned how to shade. Now let's go to the next part of of getting individual probabilities. So this is the area under the probability is the area under the normal distribution curve, and is got from mathematical tables or of cumulative normal distribution. So now I believe you have your mathematical logbooks with you, because we are going to use them very frequently in this topic. So, and the table we are going to use is the one for cumulative normal distribution. So you should be keen, because there are two tables. One has only the word normal distribution, but the one of interest is one which also has the word cumulative. So we are going to use the table of cumulative normal distribution in this video. So for you to get the probabilities, like we saw in the previous part where we were shading on the standard normal curve, the standard normal curve has a random variable z, but usually the probabilities which will be given will have a random variable x. Just as you see these probabilities, they all have random variable x. So when it is still x, you cannot use the standard normal curve, so you have to first convert it to z using this formula that z is equal to x minus mean over standard deviation. After converting to z, then you can show the probability on a standard normal curve, and then after which you can use the cumulative normal distribution. So what you should remember is that always the random variable x must be converted to random variable z in order to show it on the standard normal curve, and after which you can use the cumulative normal distribution to get the required probability. And what you should remember is that this z value got after using this formula must be to 3 decimal places. So the z value is 3 decimal places, and the probability at the end is 4 decimal places. You should not confuse the two. So with that, now let's go to question 2. So question 2 says, find the following probabilities. So part A, the probability of x less than 50 if x follows a normal distribution with mean 40 and variance 25. And part B, probability of x greater than 28 if x follows a normal distribution of mean 24 and variance 6. And lastly, probability of x greater than 52 but less than 63 if x follows a normal distribution with mean 50 and variance 5 squared. So we shall start with part A. So part A, they want the probability of x less than 50 if this x is a random variable which is normally distributed with mean 40 and variance 25. So the first thing to do is to standardize, in other words, to convert from capital X to capital Z. I think we see that in this part, which if you look at these two parts, this is capital X, this is capital Z. That means that this value has to be converted to a Z value using the formula which you have seen in the previous slide of x minus mean over standard deviation. So in this case, the x value is this 50, which is given in the question, and the mean is here. Remember we said if this is capital N, it means that this first value is mean and this one is variance. So the mean is here and this is variance, but a good thing we know that standard deviation is the square root of variance. So to get standard deviation, you shall get the square root of that value and put it there. The next is to use a calculator. So when I use a calculator to simplify this part, I'll come up with 2.000. So what you should realize is that the inequality sign is maintained. Here it was the less than, even here too should be less than, and at the end it should also remain less than. So the inequality sign is maintained. It is only the random variable which changes. It was capital X here, and after standardizing it becomes capital Z. So now that we have standardized, also we have changed from capital X to capital Z, we can now show this probability on a standard normal curve. So we shall first draw a standard normal curve with mean at 0 at the center. Then we shall look at this value. Now this value is a positive value, meaning that it will lie somewhere in this part. So let us put it there. After that, we shall look at the inequality. Inequality says z less than 2.000. It means that from this value less than, you shade going to the left. So we are going to shade all that part. So let's do that. Okay, then after that we remember that phi means probability from 0 to that value. So phi of 2.000 is the probability from 0 up to that value, which is 2.000. And this other part, I think we realize that the whole of this half has been shaded, meaning that the probability there is 0.5. Now this probability which they want here is the probability of the whole of everything that has been shaded, in other words, from here up to here. And for you to get that probability of whatever has been shaded, it means we're going to add this to this. So let's write that. As you can see here, that this probability is equal to 0.5 plus phi of 2.000. We have to add this and this to get what has been shaded. Now after that, you ask yourself, how can I get this probability of phi 2.000? So that is where the mathematical table comes in. So get your mathematical tables and open the part which has cumulative normal distribution. Like I said, there are two mathematical tables. One mathematical table, one has only normal distribution, but the one we are interested in is the one which also has the word cumulative normal distribution. So when you get that table, this is how it looks like. It has here z, then here it has values from 1 to 9, from 0 to 9, but here it is from 1 to 9, and it has here add, then here there are values of z. Now this column here shows values of z with 1 decimal, and this one shows the second decimal point of z, and this one shows the third decimal point of z. That is why I told you that when you are calculating or standardizing, the z value must be to 3 decimal places. Always remember that. So those are the z values. Now these values in the body, all these values in the body are the probabilities, we shall see how we can use them to get the probability of interest. So in this case, in this question, they want to get phi of 2.000, so it is 2.0. So what you're going to do, like I said, the first decimal point is got in this part. So in this part you will look for 2.0, which is here. Then the second decimal point is got in this part, and since it was 2.00, the second decimal point is 0, which is there. Now the third decimal point is got in this part, and the third decimal point was 0, but since this one starts from 1, it implies that 0 is ignored, therefore we shall take only this and that. Now the intersection, if you stand here and go horizontally and stand here and go vertically downwards, the probability you reach on is this one, which is 0.4772. Now that is the probability of interest, and that is what we are going to put under phi. So what I didn't tell you is that this table shows probabilities with phi. So the probability of phi, so this phi 2.000 will be 0.4772. But remember, there was also this 0.5, so when I add the 2, I'll come up with 0.9772. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, and this one has to be to 3 decimal places. Then M1 for addition, for you to know that you are going to add this probability to this probability. Then B1 for table value, for you to be able to use the table value, the table correctly and read off this probability correctly. That is also B1, and A1 for the output after adding. So that has been part A. Now we shall go to part B, where they want the probability of x greater than 28 if x is and follows a normal distribution with mean 24 and variance 6. So still we shall do the same. We have to first standardize to change from capital X to capital Z. So when I change, the formula is still the same, x minus mu over standard deviation. So x is this value which is there, then the mean is this value which is there, and standard deviation is square root of variance, which was there. So when I use the calculator to simplify this, I'll come up with 1.633, and we should remember that the final answer here must be to 3 decimal places. Then also the inequality sign does not change, it must be maintained. For example, here it was greater than, even here it is greater than, and even here it is greater than. So after that, we shall now draw our sketch of the standard normal curve. So it is always the same with mean at the center of which is 0. Then next is to look at this value. This value is positive, meaning that it will lie in this part of the curve. So let it be there. After that, we look at the inequality. This one means greater than. Greater than means you shade going to the right. So let's shade that. Okay. Then after that, you shall remember that phi denotes probability from 0 to that z value. So from here to here is phi of 1.633. What does that mean? It means that this shaded part will be 0.5 minus phi of 1.633. So I think you know why we are saying this, because the total of this and this must be equal to 0.5, because from here up to here is 0.5, and from here up to here is phi of 1.633, meaning that this remaining part will be got by subtraction. So this probability is this shaded area, therefore we shall come and write that that probability is equal to 0.5 minus phi of 1.633. Then we shall use a mathematical table to get this value of 0.4487. So let's see how it is got. So first of all, like we said, the first decimal point comes in this column, so 1.6 is there, The next decimal point is 3 because it was 1.633, so the second decimal point is 3. So we shall come at this column and look for 3. So take it down and look for this intersection of this and this, which is that. Then the third decimal point was also 3, so come in this part of third decimal point and look for 3, then take it down to meet this very horizontal line. So the easiest way to do it, you put here a ruler where you see this dotted line. For you on your mathematical table, you put there a ruler so that you get a correct value. So what are getting those values? We have got 4484 and 3. So how do they use them? What you should remember is that probability must be to 4 decimal places. So if you look at these first values, they were helping you by putting there 0.0.0, but these other values, because of space, they couldn't put them there. So what you should remember is that the probability must be to 4 decimal places. So if you look at this, these are 4 digits, meaning that to make 4 decimal places, it will be 0.4484. So this one corresponds to this. But for this one, to make it 4 decimal places, it will be, you add the 3 zeros in front of it, so it will be 0.0003. So these are 4 decimal places, 1, 2, 3, 4. So always remember that the probability must be to 4 decimal places. So the values got here, you have to change to make them to 4 decimal places. So when we add this and this, we shall come up with 0.4487. So that will be the the value of phi 1.633. Therefore, that we shall come here and substitute for phi 1.633 to become 0.4487. And when I subtract these two, I'll come up with 0.0513 as my answer. So let's see how marks can be awarded. So M1 for standardizing, this M1 for this subtraction, and B1 for reading the table value correctly, and A1 for output. So that has been part B. Now we shall go to part C, which says that find the probability of x greater than 52 but less than 63 if x follows a normal distribution with mean 50 and variance 5 squared. So the first step is to standardize. Like I said, you maintain the inequalities, but you keep on changing this. So this was capital X, it becomes capital Z. And when it becomes capital Z, it means that this value has to be standardized by using the formula that x minus mean over standard deviation. So this one is our value of x, then the mean is here, and standard deviation is the square root of variance. So square root of this gives you 5, which is there. You do the same for this 63. So 63, that is the value of x minus mean over standard deviation, which is the square root of variance. The inequality signs must be maintained. You see this one, it is the same as this, and this is the same as that. So next is use the calculator to simplify to 3 decimal places. So the whole of this to 3 decimal places is 0.400, and this one to 3 decimal places is 2.600. After that, now we have to sketch the probability. So first of all, you have to know that the sketch is standard with mean at the center 0. Then after that, we realize that both values are positive, meaning they will both be this side. But the first one must be the one closer to 0. So 0.4 is 00 is closer to 0, so we shall first put it there, closer to 0, followed by this, which is further away from 0, so we shall put it there. Then now this probability is the area from this up to this, so I have to shade from 0.4 up to 2.6. When we shade, we shall come up with that. Then after that, we shall remember that phi means probability from 0 up to that z value. So to get this shaded part, it will be phi 2.600, which is from 0 up to 2.600, minus phi 0.400, which is from 0 up to 0.400. So this remaining part will be got by subtraction. That's why you see here they are being subtracted. After that, you shall remember that this probability is equal to this shaded area, so you shall come and write down that is equal to phi of 2.600 minus phi of 0.400. After that, we shall use our mathematical tables. So if you look at this mathematical table, you want to first look for 2.600, so 2.6 is here and 0 is here, so it corresponds to that. But this third decimal point, like because it starts with 1, it implies that the third decimal point of 0 is ignored, so we shall take 2.60, which is 0.4953. Then the other one was 0.400, so 0.4 is here, and the second decimal point is 0, which is there. The third decimal point is 0, but 0 is not here, so it can be ignored, so we shall get our probability as 0.1554. So those are the values we are going to write. So when we come here, we shall write this as that and this as that, and when we subtract, we shall come up with 0.3399. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, and the values must be to 3 decimal places. M1 for this subtraction, B1 for this first table value, and this one for the second table value correctly read, and A1 for the output after subtraction. So that has been individual probabilities. Now we shall go to part C, which talks about symmetrical probabilities. So this one is not far different from the previous one, but the only difference is that by symmetry, the probability of z of phi, the probability of when z is negative zp, and this probability when z is positive, they are the same by symmetry. So phi of negative zp and phi of zp are the same. In other words, the probability of z taking on values between negative zp and 0, and the probability of z taking on values between 0 and positive zp will be the same because they both cover the same area. So always remember this. So in this part of symmetrical probabilities, this is the only element we are going to add in. Now the reason why we do this is because in your mathematical tables, I think you realize that there are no negative values of z. Therefore you have to remember that by symmetry, the negative values of z will be the same as the positive values of z. Then you can proceed with your working. So since that, I hope it has been understood. Now we shall go to question 3. Question 3 says, find the following probabilities. 1 is probability of x greater than 107 if x follows a normal distribution with mean of 120 and variance of 40. And part B, x less than 15 if x follows a normal distribution of mean 17 and variance 3 squared. And part C, probability of x greater than 0.45 but less than 0.55 if x follows a normal distribution with mean of 0.6 and variance of 0.04. And lastly, probability of x greater than 240 but less than 280 if x follows a normal distribution with mean 260 and variance 15 squared. So now we shall start with part A. So part A says they want the probability of x greater than 107 if x follows a normal distribution of mean 120 and variance 40. So the first step is always to standardize. So we shall standardize this. Capital X becomes capital Z, and this inequality sign is maintained, but this one x value changes to a z value, which is x minus mean over standard deviation, which is the square root of variance. So when I simplify this using a calculator and I round off to 3 decimal places, I'll come up with negative 2.055. After that, next is to sketch. So I'll first draw a standard normal curve with mean at the center 0. Then I realize that this value is negative, meaning that it's on this side of 0. So I'll put it somewhere there. Then I'll look at this inequality. Greater than means shading goes to the right. So I'll shade going that side. So let's do that. Okay, now that I remember that phi means probability from 0 to a z value. So from here up to here, the probability is phi of negative 2.055, and the whole of this area is shaded, meaning the probability will be 0.5. Now this given probability is the whole shaded part, so it will be this plus this to give me that. So I'll come here and say that the required probability is 0.5 plus phi of negative 2.055. But remember, like I said, by symmetry, our mathematical tables don't have negative values of z, so we shall remember that by symmetry, phi of negative z value is equal to phi of a positive z value. So in this step, we shall come and say that is the same as this one is the same as phi of positive 2.055. Now that I've got that, next is to use a mathematical table to come up with the value of phi 2.055. So 2.0 is there, then second decimal point is 5, they intersect at that point, then third decimal point is also 5, it intersects at that point. So after that, you remember that the probabilities must be to 4 decimal places. So these are 4 digits. To make to 4 decimal places, I'll only add 0 point. But this one is 1 digit, so I'll have to first add 3 zeros and then I add a 0 point, so it will become 0.0002 to make them 4 decimal places. After that, I'll use a calculator to add these two to come up with 0.4800. So that is the probability of phi 2.055, and that's what I'll come and write here. So this is that. Then when I use a calculator to add these two, I'll come up with 0.9800. So basically that's what they wanted. Let's see how much can be awarded. M1 for standardizing and should be to 3 decimal places, M1 for this addition, and B1 for reading the table value correctly, A1 for the output after adding. So now we shall go to part B. So part B says find the probability of x less than 15 if x follows a normal distribution with mean 17 and variance 3 squared. So the first step is always standardizing. So this is capital X, this becomes capital Z. The inequality sign is maintained. Now this X value is what should be converted to a Z value. So 15 is there, minus mean there, over variance, which is square root of standard deviation. So when I use the calculator to simplify this and round off to 3 decimal places, I'll come up with negative 0.667. After that, I have to sketch. So in sketching, I remember that this one is a negative value, meaning that it lies on this side of 0. So let me put it somewhere there. After that, I look at the inequality. Less than means your shade going to the left, so I'm going to shade that part. Then from there, remember that phi means probability from 0 to a z value. So from 0 to this value is equal to phi of negative 0.667. But since the whole of this is 0.5, it means that the remaining part is 0.5 minus phi of negative 0.667. Therefore, this probability is equal to the shaded part, which is 0.5 minus phi of negative 0.667. Then from here we shall remember that by symmetry, phi of a negative z value is equal to phi of a positive z value. After that, I have to look for this value in mathematical table, so 0.667. So 0.6, the first decimal point is 6, second one is 6, so it goes there, and third one is 7, so it goes there. After that, I remember that the probability must be to 4 decimal places, so these are 4 digits. I'll have to just add 0 point, but these are 2 digits, so I'll have to first add 2 digits, 2 more zeros before I add the 0 point. So that's why here it is 0.2454 and here it is 0.0023. The next is to use the calculator to come up with 0.2477. So that will be the value. I'll come and write under that, and when I use the calculator, I'll subtract and come up with the probability as 0.2523. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, and this should be to 3 decimal places. M1 for this subtraction, B1 for reading the correct Z value, and A1 for the output after subtraction. So now we shall go to part C. Part C is find the probability of x greater than 0.45 but less than 0.55 if x follows the normal distribution with mean of 0.6 and variance of 0.04. So the first thing is to standardize. The inequality signs must remain the same, so this x becomes z, but the inequality signs are maintained. I think you see this is maintained and this one is also maintained, but this x value has to be converted to a z value by using the formula that x minus mean over standard deviation. So this is an x value and this is the mean, and this standard deviation is the square root of variance. Similarly, this one must also be converted, so that is the x value, mean is that, and standard deviation is square root of variance. After that, we shall use our calculator, and if I use a calculator to simplify this and round off to 3 decimal places, I'll come up with negative 0.750, and this one rounding off to 3 decimal places, I'll come up with negative 0.250. Now next is to sketch a standard normal curve. So remember that this one is both a negative. This is negative and this is negative, meaning that both will lie this side of 0, but negative 0.250 is closer to 0 than negative 0.750, so we shall put negative 0.250 closer to 0 and this one further away from 0. After that, this area from between this value and this value will be the whole of this shading from here up to here, so we shall shade that. Other we shall remember that shaded part will be equal to phi of negative 0.750 minus phi of negative 0.250. Why? Because phi of negative 0.750 is the probability from here up to here, and phi of negative 0.250 is from here up to here, meaning that the remaining part will be got by subtraction. Therefore, this probability is equal to this shaded area, so we shall come and write it down here. And now next is to use the mathematical table to come up with this value and this value. So 0.75, 0.7 is here. The other value is this. So I think you realize that when you move this side, when you reach here, this is an empty space, meaning that you have to move down because these values are still values of 0.7. Therefore, when you drop down, it will land on this one, which is 2734. The third decimal point was 0, so it is ignored because here there is no 0. The next is the probability of 0.250. So 0.2 is there, then you also look for 5 here, drop it down to meet this line, and the value is 0987. Now most students forget this 0, but this 0 is there, so you shouldn't ignore it. Therefore, this probability here, it will be, like I said, there should be 4 decimal places. So this one will be 0.2734, and this one will be 0.0987. So you come and substitute. So by symmetry, this is that, this is that. So when you substitute, you come up with this for this and this for that. Then you subtract to come up with the final answer as 0.1747. So basically that's what they wanted. Now let's see how marks can be awarded. M1 for standardizing, they should be to 3 decimal places. M1 for this subtraction, B1 for this first Z value, another B1 for this second Z value, A1 for the output after subtraction. So now we shall go to part D, where they want the probability of x greater than 240 but less than 280. If x follows a normal distribution with mean 260 and variance 15 squared. So the first thing to do is to standardize. So standardizing, this capital X becomes capital Z. The inequality sign is maintained here and here. But the value, this is our next value, it has to be converted to a Z value using the formula that x minus mean over standard deviation. So this is the value of x, the mean is 260 and standard deviation is square root of variance. Similarly, this one has to be converted, so x is there, then the mean is 260 and standard deviation is square root of variance. Now next is to use a calculator and round off to 3 decimal places. So when I simplify this using a calculator and round off to 3 decimal places, I'll come up with negative 1.333, and this one round off to 3 decimal places, I'll come up with positive 1.333. So next is to draw our sketch. So this is the negative value and this is the positive value. So the negative value will lie this side of 0 and the positive value will lie this side of 0. So we shall start with the negative value, which is that, and the positive value, which is that. Now shading means that they want values from negative 1.333 up to positive 1.33. So from here up to here, that is what we are going to shade. I have to remember that phi means from 0 to a Z value. So this is phi of negative 1.333 and this is phi of positive 1.333. So this probability is equal to the shaded part. So the shaded part will be got by adding this and this. So when I add these two, I'll be able to come up with this probability which they want. So I'll come here and say that this probability is equal to phi of negative 1.333 plus phi of positive 1.333. After that, I remember that by symmetry, this one is the same as this. Therefore, I'll go back in my mathematical table and look for 1.333. So 1.3 is here, then the second decimal point is 3, so it is here, drop it down to it will intersect at that point. Then the third one is also 3, so drop it down, it intersects at that point. After that, you remember that probability must be to 4 decimal places. So these are 4 digits, so to make it 4 decimal places, you just add 0 point here. But this is 1 digit, meaning that to make it 4 decimal places, you have to first add 3 zeros to make, and then after which you will add 0 points, so it becomes 0.0005. Then from there we shall use a calculator. So this plus this gives you 0.4087. So that is the probability. We shall come and write on both this and that. both this and that. So when we add, we shall come up with 0.8174. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, and this value has to be to 3 decimal places. Then M1 for this addition, B1 for this Z value, sorry, table value, and this one for this table value, and A1 for add output after addition. So now we shall go to normal distribution in real life situations. So basically the 3 parts we have learned were introduction to normal distribution. So this part we shall begin doing questions which can be set in an examination. So I believe that in the introduction part you have learned how to sketch the standard normal curve and shade the wanted region, then also to standardize a given probability from random variable x to random variable z using this, and also how to use mathematical tables to identify the required area. Therefore, if you are keen, you must have realized that in the part of the standard normal curve we are not awarding marks for it. Why? Because the standard normal curve is meant to help you identify, or to help you represent the given probability in terms of phi, because the cumulative normal distribution table is only used for probabilities of phi. So from this part onwards we shall not be drawing the standard normal curve, because I am sure you have learned how to draw it and how to represent the given probability in terms of phi. So we shall start with part A. Part A is standardization, like we already learned, is the process of obtaining z value from random variable x using this formula that z is equal to x minus mu over sigma, where sigma is the standard deviation, mu is the mean, and this one is the random variable given in our question. So questions under this part will be in word problem. So you start with question 4. Question 4 came from UNEB 2019 paper 2 question 7, and it says the amount of meat sold by a builder is normally distributed. So in questions of normal distribution, this word must appear. For you to know that you are going to use normal distribution, you have to see this word. So it's normally distributed with mean 43 and standard deviation for kilograms. Determine the probability that the amount of meat sold is between, so the keyword to use here is the word between, so between 40 and 50 kilograms. So you must be able to represent this word between in terms of mathematical inequalities. Therefore, between 40 and 50 is expressed in this way, that x is greater than 40 but less than 50. Then, like we have always done, the first thing to do is to standardize. So you have to change, I think we realize this is x and this is z. Then the inequalities are maintained here and here. Then this 40 is standardized, so it was 40, now it will become 40 minus mean, which is 43, over standard deviation, which is 4. Similarly, this 50 has been changed, standardized. It was 50, so it will be 50 minus mean, which is 43, over standard deviation, which is 4. Then next is use the calculator to simplify. So this one gives you negative 0.75 and this one gives you 1.75. So next is to express in terms of phi. What you should remember is that as long as the signs are different, we have to add. If the signs are the same, then we have to subtract. But in this case, these signs are different. This is negative and this z value has a positive, meaning you have to add. If not, you have to draw a standard normal curve so that you can find out whether you have to add or subtract, but in the end you realize that you have to add. So next is to get these values from the mathematical table. So let's start with 0.75. So 0.75, This is 0.7, so you'll go up to 5. 5 is here, so the intersection is 2734. Like we said, they have to be 4 decimal places, so it will be 0.2734. And for the one of 1.75, it will be 1.7 is there, then 5 is here, so intersection is 4599. So to make it to 4 decimal places, it will be 0.4599. Therefore, you shall come here and substitute for phi 0.75 and for phi 1.75. Then when we add these two, we shall be able to get the required probability, which is 0.7333. So basically, that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, and this M1 is for addition, so it will be given at this point, adding these two, knowing that you have to supposed to add B1 for obtaining this table value correctly, and another B1 for reading the table value this correctly. Then A1 for add for the output after addition. So now we shall go to question 5. Question 5 came from UNEB 2013, paper 2, question 7, and it says, an industry manufactures iron sheets with mean length of 3 meters and standard deviation of 0.05 meters. Given that the lengths are normally distributed, so always this word has to appear for you to know that it's a normal distribution. Find the probability that the length of any iron sheet picked at random will be between 2.95 and 3.15. So the keyword here is between. So you have to first represent it in a mathematical one. It will be x is greater than 2.95 but less than less than 3.15. After that, we have to standardize. So this one will be standardized. It will be 2.95 minus the mean, which is 3, over standard deviation, which is 0.05. Then this one also standardized to be that minus the mean, which is 3, over the standard deviation, which is 0.05. The next is to simplify. When I simplify this using a calculator, I'll come up with -1, and when I simplify this using a calculator, I'll come up with +3. So in terms of phi, because the signs are different, we have to add. So by symmetry, this phi of -1 is equal to phi 1, and phi of 3 is this. Why? Because in the mathematical table there are no negative values, so we have to use symmetry. So next is to use mathematical tables to come up with these values of phi this and phi that. So let's start with phi 1.00. So 1.00 is 0.3413, and the one of 3.00 is, this is 3.0 and this is 0, so the intersection is 0.4987. So you come and substitute for phi 1 and phi 3 to come up with the required probability, which is 0.8400. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, M1 for this addition, B1 for this table value, another B1 for this table value, and A1 for the output after addition. So now we shall go to question 6. Question 6 came from UNEB 2000, paper 2, question 15, and it says, a sugar factory sells sugar in bags of mean 50 kilograms and standard deviation 2.5 kilograms. Given that the weights of the bags are normally distributed, so this word must appear. Find Roman 1 the probability that the weight of any bag of sugar randomly selected lies between, so this is the keyword there, between 51.5 kilograms and 53. Then Roman 2, the percentage of bags whose weight exceed, so the keyword here is exceed, 54 kilograms. Then Roman 3, number of bags that will be rejected out of 1,000 bags purchased for weighing below, so the keyword here is below 45 kilograms. So here Roman 1 is between, Roman 2 is exceed, and Roman 3 is below. So you must know what those words mean and how they are expressed mathematically in terms of inequality. So you start with Roman 1, the probability of weight, the probability that the weight is lying between 51.5 and 53. Remember, the mean is 50 and standard deviation is 2.5. So between is represented by this mathematically, meaning that x is greater than 51.5 but less than 53. After that we shall standardize, so 51 becomes 51 minus mean, which was 50, over standard deviation, which was 2.5. And this one is also standardized to become 53 minus 50 over 2.5. After that we use the calculator to simplify. So when I simplify this, I'll come up with positive 0.6, and when I simplify this, I'll come up with positive 1.2. Now because these are the same signs, both are positive, it means that we have to subtract. So always remember that when their signs are different, you add, and when the signs are the same, you subtract. If you can't remember that, then you have to draw a standard normal curve for you to identify that. So next is to read the value to get the value of phi 1.2 and phi 0.6. So let's start with phi 1.2. So phi 1.2 is 0.3849 and phi of 0.6 is 0.2253. So shall come here and substitute for phi 1.2 and phi 0.6. Then when you subtract, you come up with 0.1592. Then next we shall go to Roman 2. Roman 2, they ask for percentage of bags whose weight exceed 54. So percentage, it means you are going to get the probability, and after that you multiply by 100. So let's get the probability that it exceeds 54. So the word exceeds means greater than. So you come and express it mathematically to become x greater than 54. After that we standardize to come up with that, and when I simplify, I come up with 1.6, which is positive. Then from there I have to express in terms of phi, and it will be 0.5 minus phi of 1.6. Then I used a mathematical table. So when I use this table, you realize that 1.6 is 0.4452. Therefore, that's why you see here this phi was replaced by 0.4452, and when I subtract, I'll come up with 0.0548. But remember, they ask for percentage, so you have to multiply by 100 to come up with the required percentage. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, and this M1 is for the subtraction, for to realize that you have to subtract. And this B1 is for both table values, this table value and this table value read correctly, and A1 is for the final output after subtraction. Then this side there is subtraction and table value. So the whole of this part has that M1, and this B1 is for the output. Then M1 is for this multiplication and A1 is for the output. So that has been Roman 2. Now shall go to Roman 3. Roman 3 says, find the number of bags that will be rejected out of 1,000 purchased for weighing below 45 kilograms. So in this case, it means that we have to first get the probability of below 45 kilograms. So mathematically, that is written as x less than 45. So after that, we shall multiply by the total number of bags to get the number of bags which were rejected. So mathematically it is x less than 45. After that we standardize to come up with -2. Then I have to express this in terms of phi, and it will be 0.5 minus phi of 2.00. So if you don't understand where this is coming from, it's better you draw a standard normal curve so that you can realize how this can be expanded to that. So next is to use mathematical tables to get the value of phi 2.0, which is 0.4772. Therefore you come here and write that this is that, and therefore when I subtract I come up with 0.0228. But the total number of bags were 1000, therefore the ones which were rejected will be this probability multiplied by the total, which is 1000, to come up with 22.8, and then we round off to a whole number, which will be 23 bags. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for subtraction and table values, so the whole of this part is M1, then B1 for the output, M1 for this multiplication, A1 for this conclusion. So that has been standardization. Now we are going to de-standardization. So de-standardization is the reverse of standardization. So in the previous part of standardization, you will get the Z value and you read its probability from the mathematical table. But in de-standardization, you are given probability and you have to identify the Z value. And such questions, they usually ask for mean and standard deviation. So the Z values can be got from the table of either critical points or cumulative normal distribution. So we have already seen this cumulative distribution, but also besides that table in your mathematical logbook, there is a table of critical points. So this value can either be positive or negative. So this point is very, very vital because most students avoid it and they think that all Z values are negative. Remember, under standardization, we use the symmetry to convert the negative Z values to positive Z values. So you must, now this time that you are given probability, it is better that you understand whether it is positive or negative before you proceed. So whether it's positive or negative depends on the given probability. We shall see how you can identify that. So question 7 came from UNEB 2018 paper 2 question 12, and it says a random variable x has a normal distribution where px is greater than 9 is equal to 0.9192 and probability of x less than 11 is equal to 0.57580. Find part A the values of the mean and standard deviation, and part B the probability of x greater than 10. So each time you see this, just know that it is standardization, or when you see that you are given probability, just know that it is de-standardization. In other words, you have to get the Z values. So let's see how this can be answered. So first of all, you start with what is given. This is what is given. Then we have to standardize. Now we don't know the Z value, so we shall let it to be Z1, but the probability remains the same. Then we expand this. When you expand it to become this, now the question is, why am I putting negative here? It is because of the sketch of the standard normal curve. If you look at the sketch, there is this option, because they said greater than, so greater than means you should going to the right, but there's also this option whereby the Z is here and you should going to the right. So the question is, which one is correct? Now if you look at this, by symmetry we said the whole of this from here up the end is 0.5, but if you look at our probability is 0.9192, meaning that it's more than 0.5, meaning it will be this, because from here going this side is 0.5, meaning that the remaining part will be the other part of 0.5 minus, sorry, of 0.9192 minus 0.5 to get this probability. So if you look now, that means that this sketch is out and this one is the one which is correct. Now because it is correct, you remember that this is 0, therefore a value on the left side will be a negative. So that is why we put a negative here. So always in this standardization, you must be keen to find out whether the Z value is negative or positive. So So now that you have realized that the z value is negative, the next is to get the value of z. So if I bring this one this side, I'll remain with phi negative z1 equal to 0.494192. Now this is the probability. You have to find out the z value which gives you this probability. That is what we call de-standardization. So let's see how that is done. So you go to your table of cumulative normal distribution, and in the body, now remember this body is what contains the probability. So in this body you look for a value close to the given probability. Now in this case we are lucky that the given probability is exactly the same as the one in the body. So if you look at this, 0.4192 is the exact probability which was given in the question. Otherwise, if it was not the same, then it would be another story. We shall look at that. Now after getting that probability, then you ask yourself which z value gives that probability. The z value is 1.40. Therefore you'll come here and say that negative z1 is equal to inverse of that, which is negative, which is 1. So this was supposed to be not supposed to be there because this negative is there. Then from there we conclude that therefore z1 is equal to negative 1.400 because they have to be to 3 decimal places. So that is now z1. Now from there we remember that z1 is got by standardizing x, and our x was 9, so it will be x, which is 9, minus mean over standard deviation, and that z1 is equal to negative 1.4. Therefore when I cross multiply, I will come up with equation 1, which is 9 minus mu, which is mean, is equal to negative 1.4 sigma. So that is the first equation. Now the second equation will be got from this other probability which was given. So we are going to still follow the same procedure. So standardize, let the standardized value of 11 be z2. The probability remains the same. Then we expand this in terms of phi. It will be 0.5 phi z2 equal to 0.7580. Now I think we realize that here now it is positive, yet here it was negative. Why? It all depends on the sketch. Like I said, the probability is what determines whether it will be positive or negative. Now if you look at these two cases, they said less than, meaning that if it is here it must be less, so you have to shade going to the left, and if it is here it must be less, so you shade going to the left. Now by sight you realize that this area is less than 0.5, but the given probability is more than 0.5. Therefore this curve is not okay, but this one is okay because only from here up to the end is 0.5, meaning that the balance will be catered for by from here up to there. So that is why we put a positive value of z. Now next is to make this phi z to the subject to come up with that, and after that we have to look for the value of z which gives you this probability, and that is what is called de-standardization. So let's see how that probability can be got. So still you go in the body. If you go in this body, you realize that here we are lucky that the probability is exactly the same as the one you are looking for, so it was got from 0.70. Therefore you come here and say that phi of z2 will be equal to 0.700, and it was got by standardizing 11. So when I standardize 11, I come up with 11 minus mu over sigma equal to 0.7, and when I cross multiply, I'll get equation 2, which is that. So when I subtract the two equations, equation 2 minus equation 1, this is what I'm going to get, because 11 minus 9 gives you 2, then negative mu minus negative mu gives you 0, so it cancels out. Then 0.7 minus negative 1.4 gives you positive 2.1 sigma. Therefore, the value of the standard deviation is 0.9524. Now, before we go to the next slide, let's see how marks can be awarded for this slide. So B1 for this Z value, and another B1 for equation 1, B1 for this Z value, another B1 for equation 2, M1 for subtracting, and A1 for the standard deviation. So we have got standard deviation. Next is to get the mean. Mean can be got from either this formula, either this equation or this equation, because we already know sigma. So from equation 1, we shall substitute for sigma and be able to get our mean as 10.3334. So that was part A. Now we shall go to part B. Part B, the one, the probability of x greater than 10. So x greater than 10, the first thing to do is to standardize. The good thing, we have got the mean, which is this, and we also know the standard deviation, which was that. When I use a calculator and round off to 3 decimal places, it will be that, negative 0.350. Next is to express in terms of phi, and it will be 0.5 plus phi of 0.350. So by symmetry, this negative becomes a positive at that point. The next is to get this value from mathematical tables. So 0.3 is there, and 0.5 is there, so it is 1368. So since it is supposed to be to 4 decimal places, it will be 0.1368. So you come here and substitute for phi of 0.350, and in the end we get the final answer. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for this substitution into equation 1, and A1 for the mean, M1 for standardization, M1 for this addition here, and B1 for reading the table value correctly, and A1 for the output after addition. So now we shall go to question 8, which came from UNEB 2017, paper 2, question 15, and says the number of cows owned by residents in a village is assumed to be normally distributed. So always this word has to be there. 15% of the residents have less than 60 cows. So 15% is a probability, which is 15 over 100 to become 0.15. Then here 5% of the residents have over 90 cows. So the keyword here is less than and the word over. So less than is the less than inequality, and over is the greater than inequality. Part A, determine the values of mean and standard deviation. And part B, if there are 200 residents, find how many have more than 80 cows. So in this part, it means you have to first get the probability of more than 80 cows. After that, you multiply by the total to get the required number of residents. So we are going to start with part A, where they want you to find the mean and standard deviation. So less than 60, probability of less than 60, it was given as 15%, which is 0.15. Then when I standardize, let this standardized value be that. So now that we are using a negative, I believe you know where the negative comes from. The next is to get the Z value, which gives you this probability. Now that Z value, like I think you remember in the introduction we said, you can either use critical points or cumulative normal distribution table. So for this case we are going to use critical points. Now, how do you know when to use critical points and when to use cumulative normal distribution? The only way is to remember that critical points is very, very brief. For example, if you look at the previous part, I think you see that from for example, the probability was 0.4192, and if I look for 0.4192, I'll come, it's under P, so here there is no, then here if I come here there is no, but okay. If you look at this, if you move from 0.400, you go to 0.450. That means that 0.4192 does not exist in critical points. So if the probability does not exist in the critical points, then the only option is cumulative normal distribution, because always cumulative normal distribution will give the entire probabilities. So this one is like a shortcut, but if it doesn't exist here, you have to use the cumulative normal distribution table. Now we are lucky that in this part the probability exists, because now if it is just greater than or less than, without starting from 0, we use Q, and if it is phi, we use P. So in this case, if you look at this probability, we had only less than a z value. That means it will be Q, but still you can go ahead and express in terms of phi. If you express in terms of phi, it will be phi z negative z1 is equal to 0.5 minus 0.15, which gives you the same value, which is just besides on the same line, which is 0.35. So any is okay. Now when I use this Q, I'll come and look for 0.15, which is here, and this is the probability though, so the corresponding z value is on that very line. So on this very line, the corresponding z value is 1.036. That means that here the z value is 1.036, as you can see it here. So next is to make z1 the subject, which will be negative. So you must be keen to find out whether it's negative or positive, because most students think it is always positive, and that is not okay. So next is to remember that this z was got by standardizing 60. So when I standardize 60, I'll come up with that. So I'll equate it to that, and when I cross multiply, it will give me equation 1. So the other one was over 90. So over 90 means greater than 90, and the probability was 5%, which is 0.05. So I'll have to standardize it. Let the standardized value be z2. Then I can use also the critical points, because that value is exactly the same as one of the values in the critical points. So if you look at this, we have 0.05, which is exactly the same as the one we have. So the corresponding z value is 1.645. Therefore, shall come here and write, and I think you realize that this is now a positive value. So I believe by now you know how to distinguish positive and negative based on the previous example. So when I remember that this one was good by standardizing 90, so I'll come and standardize 90 to equate it to 1.645. Cross multiply to get equation 2. Then I have to solve those two equations by subtracting 1 from 2 to come up with 30 equal to 2.681 sigma. Therefore sigma, which is standard deviation, is 11.1899. Then I can use either equation 1 or equation 2. If I use equation 1 and substitute for sigma, I'll come up with that step, meaning that mu is the only unknown. Therefore mu is 71.5927. Therefore the standard deviation was this and mean is that. So basically that's what they wanted in part A. Now let's see how marks can be awarded. So B1 for this z value, the negative must be seen, and B1 for this equation 1, B1 for the z value, B1 for equation 2, M1 for subtraction, A1 for standard deviation, M1 for substitution, A1 for mean. Now in part B they said if there are 200 residents, find how many have more than 80 cows. So more than means greater than 80. So we shall first get the probability of x greater than 80, then you multiply the total number of residents to get the required number of residents. So x greater than 80, the good thing we have got the mean and standard deviation, so we can standardize to come up with 0.752 and should be to 3 decimal places. The next is to express in terms of phi to become 0.5 minus phi 0.752. Then from there we shall get the value of phi 0.752 from our table. So 0.75 is here. So this is the value for 0.75, which is there. But remember it was 0.752, so you have to go in this third decimal place and look for 2 until 6. So to 4 decimal places it will become 0.0006. So I believe you know how this one comes about. Now when we add, we shall be able to come up with 0.2740. So you come and substitute for phi that to go, and in the end you shall get the probability as 0.2260. So the total was 200, so we shall multiply this probability by 200 to come up with what is required, and when you round off it will be 45 residents. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for subtraction and table values, so this point step M1, B1 for output, M1 for multiplication, A1 for conclusion. So now shall go to question 9. So question 9 came from UNEB 1993, paper 2, question 12, and it says the lifetime of a bulb is normally distributed. So this word must exist for normal distribution, with mean 800 hours and standard deviation 80 hours. The manufacturer guarantees to replace bulbs which blow after less than 660 hours. So that is x less than 660. Part A, what percentage of bulbs will he have to replace under the guarantee? And part B, the manufacturer is only willing to replace a maximum of 1% of the bulbs. What should be the guaranteed lifetime of bulbs? Part Roman 3, instead of reducing the guaranteed lifetime in Roman 2, the mean lifetime was increased by superior technology. What should be the new mean so that only 1% are replaced if the guaranteed lifetime remains at 660 hours but the standard deviation is reduced to 70 hours? So we shall start with Roman 1, where they want the percentage of bulbs that will have to be replaced under the guarantee. Remember, the guarantee replace those which blow after less than 660. So that means that we have to first get the probability of x less than 660, after which we multiply by 100 to get the required percentage. So you should remember that the mean is 800 and standard deviation is 80. So we shall come and write probability is x less than 660, then we standardize to come up with negative 1.75. Then next is expressed in terms of phi and to read the table. So when I read the table of 1.75, it will be 0.4599, which is that, and then to come up with 0.0401. After that, we shall multiply it by 100 to get the required percentage, which should be 4.01. So that was Roman 1. Roman 2, the manufacturer is only willing to replace a maximum of 1% of the bulbs. What should be the guaranteed lifetime of the bulbs? So 1% is the probability, so we have to de-standardize. Therefore, we shall come and say that let the lifetime be x1. So probability of x less than x1 will be 1%, which is 0.01. When I standardize, it will become that, and when I get the z value, it will be negative 2.326. So this value is got from the critical point. So if you look at the critical points, of this is under true because it was only one value. If it starts from 0 to a z value, we use p, but if it starts from a z value and onwards or less than, we shall use true. So true, we look for 0.01, which is that. Therefore, the corresponding z value is 2.326. And because this one is smaller than 0.5, it will be negative. Therefore, when I cross multiply and make x1 the subject, it will be 613.92 hours. So basically, that's what they wanted in Roman 1 and Roman 2. Now let's see how marks can be awarded. So M1 for standardizing, another M1 for this subtraction, sorry, it gives one at that point. Then B1 for the table value, another B1 for the output, M1 for multiplication, and A1 for the output. Then here M1 for standardizing, so for standardizing, and M1 for equating the table value, and A1 for the output. So now we shall go to Roman 3. Roman 3 says that instead of reducing the guaranteed lifetime to in Roman 2, the mean lifetime was increased by superior technology. What should be the new mean so that only 1% are replaced if the guaranteed lifetime remains at 660 hours, but the standard deviation is reduced to 70 hours. So here the mean is what they want, and the standard deviation is 70 and the x is 660. So we shall come and say that probability of x less than 660 is 0.01. When I standardize, it will become that because mean we don't know it and so one we are looking for. Then we already saw that this probability has a z value of that, therefore we shall equate the two, but it will be negative. Then when I cross multiply and make mu the subject, it will be 822.82 hours. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, M1 for equating the two, table value and that, and A1 for the output. So that has been de-standardization. Now we shall go to part C. Part C says normal approximation of binomial. Now if you remember, under binomial, the mathematical tables for binomials stop at n equal to 20. Now the question is, what if a question is a binomial distribution and the value of n is more than 20? So if that is the case, then we have to approximate it to from binomial to a normal distribution, and we're using a mean of NP. I think remember this formula under binomial distribution, and standard deviation of this square root of NP2. I think remember that also under binomial distribution. And when you use this and this, you can standardize the given probability, and that will, so that we can read the value from the table value. But before we standardize, you have to remember something called continuity correction. Now continuity correction is what helps us to approximate a binomial distribution to a normal distribution, and this is done by either adding or subtracting 0.5 to the upper and lower limits of the binomial distribution as the case may require. So for and this depends on whether the distribution is wanted or unwanted. So for you to find out whether you are supposed to add or subtract 0.5 depends on whether the limit is wanted or unwanted in the distribution. And this value of 0.5 is what we call the continuity correction. So always when you are changing from binomial to normal, you must carry out continuity correction. This is what helps you to convert from a discrete probability to a continuous probability. So we shall see how continuity correction is done. Now we shall go to question 10. Question 10 came from UNEB 2004 paper 2 question 5 and says 20% of eggs supplied by a poultry farm have cracks on them. Determine the probability that a sample of 900 eggs supplied by the farm will have more than 200 eggs with cracks. Now if you look at this question, it does not have anywhere the word normal distribution, meaning it is not a normal distribution. But because of this value of n, it implies this value of n and this probability, it implies that it is a binomial distribution with p of 20%, which is 0.2, and n of 900. But if you look at your binomial mathematical tables of binomial distribution, you realize that n stops at 20. So always when n is more than 20, we no longer use mathematical tables because the values are not there. What we do, we approximate it first to a normal distribution, then we standardize, and after we use mathematical tables. So the probability they want is the probability of more than 200, which is x greater than 200. So that is what we are going to first write. N is, first of all, n is 900, p is 0.2, and q is 1 minus p, which is 0.8. When we know that, we can first get our mean, which is np, and to be 900 times 0.2, which is 180, and our standard deviation, which is square root of npq, which is 12. Now after that, we are good to go. So we shall say that by continuity correction, probability of x greater than 200 is 10, becomes probability of x greater than 200.5. Now the question is, why have we added 0.5 and not subtracted 0.5? So like we said, we either add or subtract 0.5. Now when I subtract 0.5, I'll come up with 199.5, and when I add 0.5, I'll come up with 200.5. Now of these two, you have to choose one. Now the question is, which one should I choose? The one to choose depends on whether this limit is wanted or unwanted in the distribution. So if you look at this, it is just x greater than 200. Now greater than means that this 200 is not wanted, therefore you start from 201 onwards. Now because it is unwanted, it means that after continuity correction, 200 must not be included. Now if we had written this 199.5 here, it means that 200 will be included because 200 is greater than 199.5. okay, but when we write this one, it means that 200 has been excluded because 200 is less than this, and the values they want are those which are greater than 200.5. so that is how you can know whether you are supposed to subtract or add 0.5. So in this case, because 200 was unwanted, we had to eliminate it by adding 0.5 on the given value. So this is the most disturbing part. And now that we have done continuity correction, now continuity correction, it helps us to convert from discrete to continuous. Now this was binomial, this is now normal. And because this is now a normal distribution, we can standardize. So when we standardize, we shall come up with 200 minus mean, which was 180, and standard deviation, which was 12. Then we use a calculator to simplify this to 3 decimal places. It will be 1.708. Then when you express in terms of phi, it will be 0.5 minus phi of 1.708. Now next is to look for that value. So 1.7 is there, and 0 is there, and the third decimal place is 8. So this one to 4 decimal places is that, and this one to 4 decimal places is this. I think you remember that. Then when I add, I'll come up with 0.4561. So I'll come here and substitute for phi of 1.708 to come up with that, and when I subtract, I'll come up with 0.0439. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for both mean and standard deviation, M1 for continuity correction and standardizing, then M1 for this subtraction, B1 for reading this table value correctly, and A1 for the output after subtraction. So now we shall go to question 11, and question 11 came from UNEB 2012 paper 2 question 15, and it says an examination has 100 questions. A student has 60% chance of getting each question correct. A student fails the examination for a mark less than 55. A student gets a distinction for a mark of 68 or more. Calculate the probability that a student fails the examination, and part B gets a distinction. Now if you look at this, they didn't mention anywhere that's a normal distribution, meaning it's a binomial, because there is n here and there is p here. So when there is n and p, it is a binomial. So you have to first convert by getting mean and standard deviation. So n is 100, p is 60%, which is 0.6, and q is 1 minus 0.6, which is p, to come up with 0.4. That means that our mean will be np, which is 60, and standard deviation will be square root of 24. So before we go to the next slide, let's give this one mark for both mean and standard deviation. So now we shall go to Roman 1. Roman 1, the probability that a student fails the examination. Remember, failing means you get a mark less than 55. So this probability of failing is equal to probability of x less than 55. So you come and say that probability that fails is equal to x less than 55. Then we do continuity correction. Now continuity correction, like we said, you can either add 0.5. So when I add 0.5, it will be 55.5, and when I subtract 0.5, it will be 54.5. 54.5. Now the question is, should I add or subtract? Remember, you either add or subtract depending on whether the limit is wanted or unwanted. Now here, x less than 55 means that 55 is unwanted, because less than the values which are wanted are those ones which are less than 55, and they begin from 54 and going downwards. Therefore, that means that you must look for a value which eliminates 55. Now if I put there 55.5 here, x less than 55.5, it means that this 55 will be included because it is also less than that. But if I put 54.5 here, the 55 will be excluded because it is greater than this. Therefore, that is why we choose this option of subtracting 0.5. So whether I subtract or sub-add depends on the whether the given limit is wanted or unwanted in the distribution. Now that we have converted from binomial to normal, we can standardize and then use a calculator to round this off to 3 decimal places, which is negative 1.123. Then in terms of phi, it is 0.5 minus phi 1.123. By symmetry, that's why this negative has become a positive. So next is to read that value from mathematical table. So 1.1 is there, another 2 is there, then the 3 is there. So this value to 4 decimal places, it is that, and this one to 4 decimal places is that. When I add, I'll come up with 0.3692. So that is what I will substitute and be able to get the probability of 0.1308. So Roman 2, they want the probability that he gets a distinction. Distinction, we said it should be 68 or more, and that in terms of mathematical inequalities, it will be x greater than or equal to 68. Now by continuity correction, we come up with this. Now the question is, why did we subtract 0.5? Like we said, we have two options. When I add 0.5, it will become 68.5, and when I subtract 0.5, it will become 67.5. But whether to add or subtract depends on whether value is wanted in the distribution. So if you look at this x greater than or equal to 68, it means that 68 is wanted in the distribution. Now because it is wanted, it means that if I put 67.5 here, 67.5 is less than 68, meaning that 68 will be included within that. But if I put 68.5 here, it means that 68 is less than this value, meaning it will be excluded. So that is why we put 67.5. Now another thing you should realize is that after continuity correction, the sign must not have or equal to. This was greater than or equal to, but in the end it does not have that, because we have done continuity correction. So this is binomial. Now we have converted it to normal distribution. Now we can standardize to come up with z greater than 1.351. Then we say express in terms of phi and look for the value of phi in the mathematical table. So if you look for that value, 1.5 is there, 3 is there, and 1 is there. So this one to 4 decimal places is that, and this one to 4 decimal places is that. When I add, I'll come up with 0.4371. So that is where this value is coming from. Then we'll subtract to come up with 0.0629. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for continuity correction and standardizing, then M1 for this subtraction, B1 for this table value reading it correctly, and A1 for the output after subtraction. M1 for continuity correction and standardizing, M1 for this subtraction, B1 for that table value, and A1 for the output after subtraction. So now we shall go to question 12. Question 12 came from UNEB 2019, paper 2, question 16, and says a biased die with faces labeled 1, 2, 2, 3, 5, and 6 is tossed 45 times. Calculate the probability that 2 will appear. Now this 45 is n, meaning it is a binomial distribution. But you must realize that this n is greater than 20, meaning we have to approximate to normal. So always when n is greater than 20, you must remember that you have to first approximate to normal distribution, then you can standardize, after which you can get the probability. So n is 45 and p is 2 over 6, because they said calculate the probability that a 2 will appear. So probability of success is the probability of getting a 2, and if you look at this sample space, the values of 2 appear twice, 1, 2, which will be this event, and the total of sample space is 1, 2, 3, 4, 5, 6. That is why you see here over 6, but you can still reduce to 1 over 3, meaning that 2 will now be 2 over 3. Therefore, mean will be equal to NP, which is that, which gives you 15, and standard deviation will be square root of 10, which gives you 3.162. Now that we know the mean and standard deviation, we can go ahead and answer the questions required. One is more than 18 times, meaning x greater than 18, and B is exactly 11 times, meaning x equal to 11. So before we go to the next slide, let's see how much can be awarded for this. So B1 for getting P and Q, and B1 for the value of mean, and B1 for the value of standard deviation. So now we shall start with part A. So part A, we shall say that let x be a random variable of the number of times a 2 will appear. Therefore, probability of more than 18 times is equal to x greater than 18. And this is now binomial. You have to change to normal by continuity correction, and after that you standardize. After standardizing, the value must be to 3 decimal places, then you convert in express in terms of phi. After that, you can now read the value from mathematical tables. So 1.107, so this is 1.1, then 0 is there and 7 is there. Therefore, this to 4 decimal places is that, and this to 4 decimal places is that, which gives you 0.3658. So I'll come and substitute for that, and in the end the probability will be 0.1342. So now we shall go to part B, where they wanted exactly 11 times. Now it becomes x equal to 11. Now this is not an inequality, it's an equal sign, meaning that both must be carried out. You have to subtract and you have to also add. And when I standardize, this becomes that and this becomes that. Then to 3 decimal places, this is that and this is that. Now since they are of the same sign, it means that in terms of phi we subtract. And then you have to read values. The good thing, we have already seen this in this part, and the z value was this, which is there, but the one we don't know yet is 1.423. so let's read that in the mathematical table. So 1.4 is there, 2 is there, and 3 is there. Therefore, this to 4 decimal places is that, and this to 4 decimal places is that. In the end, we come up with 0.4226. So this is that, and this is that. When you subtract, you come up with 0.0568. So basically, that's what they wanted. Now let's see how much can be awarded. So M1 for continuity correction and standardizing, then M1 for subtraction, B1 for table value, and A1 for output after subtraction. M1 for continuity correction and subtraction, M1 for continuity correction and standardization. This M1 is for this subtraction, B1 is one Z value, another B1 for the other Z value, and A1 for the output after subtraction. So now we shall go to the next part, which is distribution of sample mean from a normal distribution. Now the normal distribution we have been dealing with has not been having a word sample, but sometimes it can have the word sample. So when it has the word sample, something changes. So we shall say, if this is a random sample of size n taken from a normal distribution with mean mu and variance sigma squared, say that x follows a normal distribution with mean mu and sigma squared, then the distribution of mean, this is a symbol for mean, is also normally distributed with mean mu and variance sigma squared over n. So this is the this is a symbol for mean or sample mean. So and this one is what we call population mean. So those two are different. And now this variance will be this. So the variance for this random variable is that. Now that means that the standard deviation for the sampling distribution is square root of this variance, which is that. Now this one has a special name and is called standard error. So when they ask for standard error, it means that they want the variance for this sampling distribution. And because the variance has changed, it means that even the z value will change. Here we are putting just x. Now we put x bar to mean sample mean, minus mu, which is the population mean, over standard error, which is sigma over square root of n. So the formula, it means that the formula has changed and you must be keen of it. So when given a question of normal distribution, the first thing to look for is that word sample. If it is normally distributed and they tell you it is a sample, it means that the formula you are going to use is this to get the value of z. So with that, we shall go to question 13, which comes from UNEB 2016 paper 2 question 15. It says the drying time of a newly manufactured paint is normally distributed with mean of 110.5 and standard deviation of 12. Part A, find the probability that the paint dries between 104 and 109 minutes. Then part B, if a random sample, now this is the keyword, if a random sample of 20 tins of paint was taken, find the probability that the mean drying time, of the sample is between 108 and 112. So in this case, if you look at part A does not have anything like a sample, meaning that it will be treated as you have been treating the previous question. So let's first begin with part A, then we shall go to part B, which has a sample. So for part A, they want the probability of x greater than 104 but less than 109. We have to standardize and use a calculator to simplify to 3 decimal places. Then because these are the same signs, it means that we have to subtract. And by symmetry, this negative becomes positive and this negative becomes positive. Then we can read those values from mathematical tables. So if I come here, 0.125, 0.125, 2 and 5. So these to 4 decimal places is that, and this to 4 decimal places is that. In the end, we'll come up with 0.498. Then the one of 0.542, 0.542, this is 0.54 and 2. So this one to 4 decimal places is that, and this one to 4 decimal places is that. Therefore, when I add, I'll come up with 0.2061. So that is what I will substitute, and then I'll come up with a probability of 0.1563. Now we shall go to part B, which has the word sample mean. So sample mean, I think realize that the difference is here. This was just x, but this is x bar. That is the first thing to note. Then 2, you realize that in standardizing, this is our value of x bar, and this is the mean, which is the same as this. But when it comes to standard deviation, here we put standard deviation and here we put standard error. Always remember that. Here we put standard error, which is standard deviation over square root of n. So when we are standardizing, that's how we do it. This minus mean over standard error, and also this minus mean over standard error. Then we shall come up with this to 3 decimal places is that, and this to 3 decimal places is that. So by symmetry, this negative becomes positive. Now we are going to read values of 0.5, 0.932 and 0.559. So let's start with 0.932. So 0.932, 3 is there and 2 is there. So this one is that to 4 decimal places, and this one is this to 4 decimal places. So then you come up with 0.3243. Then the other one is 0.559. So 0.55 is there to 4 decimal places, and this is there to 4 decimal places. In the end, you come up with 0.2119. So when I substitute, this is that and this is that, so in the end I'll come up with 0.5362. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for this standardizing, and M1 for this standardizing, M1 for the subtraction, then B1 for the first table value, another B1 for the second table value, A1 for the output after subtraction. Then your M1 for this standardization, M1 for this standardization, M1 for this addition, B1 for the first table value, another B1 for the second table value, A1 for the output after addition. So now shall go to question 14. Question 14 came from UNEB 2009, paper 2, question 15A, and says the masses of soap powder in certain packets is normally distributed with mean 842 and variance 225. Find the probability that a random sample, know this word random sample, that one is very key because when you're standardizing, the formula will have somehow changed. Random sample of 120 packets has a sample mean with mass between 844 and 846, then Roman 2 less than 843. So we shall start with Roman 1 of between. So between is that, realize that we are using here the symbol for sample mean. Standardizing, this will be that of minus mean over standard error, and this will be this minus mean over standard error. To 4 decimal places, this becomes that and this becomes that. So in terms of phi, because it is same sign, you have to subtract. Then we shall read those values. So let's start with the one of 2.921. So 2.921, 2.9 is there, 2 is there, and 1. I think you see that this is blank, meaning it is ignored. So we are going to take only this one, which is 0.4982. The next is 1.461. So 1.461, 1.4 is there, 6 is there, and 1 is there. So this to 4 decimal places is that, and this to 4 decimal places is that. And then you come up with 0.4280. So next is to substitute those values and come up with a probability of 0.0702. That was Roman 1. Now Roman 2, they wanted a probability of less than 843, but you realize that this is a sample mean, meaning that when you're standardizing, to be this minus mean, population mean over standard error. Then to 3 decimal places it is that, and in terms of phi it is that. Then we shall read its value. So when I read its value, it will be 0.2673. So I'll come here and substitute that value, and then I'll come up with a probability of 0.7673. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, M1 for subtraction and table values, so for all this part, and A1 for the output. Same story, M1 for standardization, M1 for this addition and the whole of that part, then A1 for the output. So that has been sample mean. Now we shall go to another part, which is confidence interval of a population mean. Now, as mentioned earlier, the mean this of a random sample drawn from a population is normally distributed with mean this. So this mu is population mean, like we have said earlier, and this one is sample mean. And variance sigma squared is also normally distributed with mean this and variance that. Variance now is the standard error, where n is a sample size. So that means that we already saw this formula, and when I make mu the subject or the population mean the subject, I'll come up with this. Now this formula is very vital because it will help us to get the confidence interval within which the mean lies, within which the population mean lies. So there's a sample mean, population mean. Now for the 1 minus alpha times 100% confidence interval of the mean, the z value leaving an area alpha over 2 to the left on the normal distribution curve is usually denoted by negative z alpha over 2, where alpha is the degree of confidence. So alpha is the degree of confidence. Now we're using 1 minus alpha, we shall see what it means. For example, if they say 99% confidence interval, it means that 1 minus alpha is equal to 99 over 100, because this 100 is already catered for here. So this one will be 0.99. That's that. When you multiply by 100, you'll be able to get the 99%. So always remember that this one is the given confidence in percentage form divided by 100. Similarly, the z value leaving an area alpha over 2 to the right is noted by positive z alpha over 2 as shown below. So this was the negative z alpha over 2, which leaves an area to the left of 0, and this one is positive z alpha over 2, which leaves an area of this. So this is supposed to be positive, so positive that. Now the area left is alpha over 2 to the left, and this to the right is also alpha over 2, meaning that from here up to here is alpha is 1 minus alpha, meaning that half of it will be alpha 1 minus alpha divided by 2. What does that mean? It means that if they say, for example, 99% confidence interval, it means that from here up to here is 99%, which is 0.99, but halfway it will be 99 over 2. So this one alone from here up to here will be 99 over 2. So the reason why we do that is because for you to get the z value, you must first get the phi, then you can do the reverse like we did under the standardization. So always remember, when they give you a confidence interval, you first divide by 2 in order to be able to get the phi, which will be used to get the z value. We shall see how that is carried out in the worked examples. By mere speaking, it may be confusing. So if variance this is known, it implies that the confidence limit of mean mu, which is population mean, is given by this plus or minus that. I think you remember this formula in the previous slide. Now the limits is why you put here plus or minus, meaning that when you put minus, you'll get the lower limit, and when you put plus, you'll get the upper limit. Then that is when they talk about confidence limit, but they can also talk about confidence interval. Now when they talk about confidence interval, it implies that the values must be put in box bracket. For confidence limit, you only state, but you state that upper limit is equal to this and lower limit is equal to this. But when they say confidence interval, the value, the lower and upper limits must be put in box bracket. So with that, we shall go to question 15. Question 15 came from UNEB 2010, paper 2, question 16, and it says part A, the chance that a cow recovers from a certain mouth disease when treated is 0.72. If 100 cows are treated by the same vaccine, find the 95% confidence limits for the mean number of cows that recover. That is part A. Then part B, the ages of the taxis on a route are normally distributed with standard deviation 1.5 years. A sample of 100 taxis inspected on a particular day gave a mean age of 5.6 years. Determine Roman 1 a 99% confidence interval for the mean age of all taxis that operate on the route. Then Roman 2, the probability that the taxis were of ages between 5.4 and 5.8 years. So we shall start with part A. Here we are given P and we are given N. So we have to first convert into normal by getting mean and standard deviation, but our aim is to get the mean of that population or the sample. So you are coming and say that the sample mean, not that we're using sample mean is equal to NP, which is equal to 100 times P, which will be 72. Then the variance will be square root of NP2, which will be given by that. Therefore, for the 95% confidence limits, it means that phi will be equal to half of it, so half of this is 0.475. And therefore this is the probability. You have to use it, we have to de-standardize to get the value of Z. To do that, we use either critical points or cumulative normal distribution cumulative normal distribution table. So when I use cumulative normal distribution, I look for the probability of 0.475, and the good thing is that we have a probability which is exactly the same as the one we are looking for, and that was got from 1.96, and that will be our Z value. So that is why you see here that Z alpha over 2 is 1.96. So now we have the sample mean, and we have the variance, and we have the Z alpha over 2, and we already have N, which is 100, meaning we can substitute in the formula for confidence limits to come up with the answer they want. So this is that which was got from there, and this is that. This one was got from here, and this N is this. So the lower limit will be got by subtracting, and the upper limit will be got by adding. So basically that's what they wanted in part A. Now let's see how marks can be awarded. So M1 for both sample mean and variance, B1 for Z alpha over 2, M1 for substitution, A1 for the lower limit, A1 for the upper limit. So this was supposed to be upper limit. So that was part A. Now we shall go to part B. Part B, they want the 99% confidence interval. So what we know is that we have the value of N, which is 100, and we have the mean, which is 5.6, and standard deviation, which is 1.5. So for Roman 1, we shall say that for 99% confidence interval, the phi will be equal to half of this, which is 0.495. Therefore, we shall also use mathematical tables This time the good thing is that this value is exactly the same as the value in the critical point. So if you look at the critical points, 0.495 is there under P. So remember, phi is the probability and the critical points is the column of P. So 5 is that. Therefore the corresponding Z value is 2.576. Therefore we shall come here and write 2.576 as our Z alpha over 2. That means that the confidence limits are given by that. So we substitute for sample mean, Z alpha over 2, standard deviation, and N. And that gives you that, implying that the confidence interval has been box bracket. This one's got by subtracting, and this one's got by adding. So Roman 2 says find the probability that the taxes were of ages between 5.4 and 5.8. So you come and standardize this to become that minus mean over standard error and that minus mean over standard error. So these two 3 decimal places is that, and these 2 3 decimal places is that, mean that the same as 2 times 5 1.33. And when you use mathematical tables, this is that and this is that. Therefore in the end we shall come up with 0.4087. So you come and say that it's equal to that, and basically that's what they wanted. So B1 for getting Z value, M1 for substitution, A1 for stating confidence interval, M1 for standardizing, M1 for multiplication and table value, this, writing this and that, then B1 for the table value, so A1 for the output. So now we shall go to question 16. Question 16 came from UNEB 2008, paper 2, question 15b, and says that times a machine takes to print each of the 10 documents were recorded in minutes as given below. So these are the times. If the times of printing the documents are approximately normally distributed with variance of this, find the 80% confidence interval for the mean time of printing the documents. So the first thing to do is to get the summation, because that summation will help us to get the sample mean. Now for the 80% confidence interval, phi of Z alpha is equal to 80%, which divided by 2, which is 0.4. Now 0.4, it means that we can get it from the table. So and from the table, 0.4 is here under P, and the corresponding Z value is 1.282. Which is that. Therefore, it implies that the confidence limits are this, but the good thing, sample mean is given by the formula summation x over n. So we are going to substitute that. So summation x over n is 179 and our n is 10. Therefore Z alpha over 2 is that. Variance, remember we are given variance, so standard deviation is square root, and square root of n is that. So therefore confidence interval, this one is got by subtracting and this one is got by adding. So basically that's what they wanted. Now let's see how much can be awarded. B1 for this summation, B1 for the Z value, M1 for mean and substitution. So M1 for this mean another M1 for substituting into the formula, then A1 for stating the confidence interval. So now we shall go to question 17, which came from UNEB 2006 question 9b. The times a factory takes to make a unit of product are approximately normally distributed. Sample of 49. So you see this word sample of the products were taken and found to take an average of 54 minutes with a standard deviation of 2 minutes. Calculate the 99% confidence limits of the mean time of all the units of the products. So for the 99% confidence limits, you already saw that this value for the Z alpha will be 2.56. We already saw that, but we can still confirm. So if you look at this 0.495, the Z value is 2.576. That means that the confidence limits are given by that formula, and the mean was given as 54. Z alpha, we have got it, and the standard deviation was given also as 2, and the value of n is 49. Therefore, the lower limit, because they asked for confidence limit, means we have to state the lower limit and also the upper limit. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for Z alpha over 2, M1 for substitution, M1 for mobiles, so it can be given at this point or at this point. Then A1 for stating lower limit, A1 for stating upper limit. Now before I conclude this video, permit me to pass on this information that as Roa Publications Limited, we have compiled a number of books for our viewers. So one of the books is A-Level Mastering A-Level Mathematics Paper 1. This book contains the entire syllabus of Uganda as per NCDC, so it contains clear notes, worked examples, and trial questions on algebra, geometry, calculus, trigonometry, and vectors. Then also another one is Mastering A-Level Mathematics Paper 2, which also contains clear notes, worked examples, and trial questions on mechanics, statistics, probability, and numerical methods. We have also compiled Mastering A-Level Physics Paper 1, and this one also contains clear notes, worked examples, and trial questions on mechanics, heat, and modern physics. We have also compiled Mastering A-Level Physics Paper 2, which contains also clear notes, worked examples, and trial questions on geometrical optics, that is light, physical optics, that is waves, electrostatics, electricity, magnetism, and alternating current. We have also compiled Mastering O-Level Physics Volume 1 of 2. This one contains notes of Senior 1 and Senior 2 with worked examples, trial questions, and their answers. We also have Mastering O-Level Physics Volume 2 of 2. It also contains clear notes, worked examples, trial questions, and their answers for Senior 3 and Senior 4 students. We have also compiled Mastering A-Level Subsidiary Mathematics Paper 1 for students offering subsidiary math. It contains all the topics and there is statistics, probability, mechanics, and pure math for subsidiary mathematics. We have also compiled UNEB questions, but this time around they have been sorted topic by topic, and from the years of from 2020 up to 1987. Those are over 36 years. So I believe it will be a very good book for students, especially in Senior 3 and Senior 4 and also Senior 2. We have also compiled UNEB questions for A-Level, and also we have compiled them topic by topic for the years from 2020 up to 1987. 8, and I believe this will be suitable for students in Senior 5 and Senior 6. We have also compiled an O-level math question, O-level physics question bank. Also still it is topical questions, so the question banks we arrange, they are topical from 2020 up to 1987, and lastly also a physics question bank topical from 2020 up to 1988. So for orders, in order to get these copies, you can contact the managing director on +256 785 609713 or +256 704 989851, or email at rowaelearning@gmail.com. So that brings us the end of this video. Thank you for watching, and be reminded that the next video will be on errors. So this video has marked the end of probability, so the next part will be numerical methods, and the first topic will be errors. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with errors has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.